You think you understand energy. You'll tell me energy is the capacity to do work, or the ability to make things happen. Or maybe you'll reach for something about motion and heat. You feel confident because you passed physics class, because you can calculate kinetic energy as half mass times velocity squared, because you know E equals mc squared. But here's what I want you to do right now. Explain to me where energy comes from. Not where you get it. I'm not asking about eating food or burning gasoline. I'm asking where energy itself comes from. What is it made of? Where did it originate? You're feeling something uncomfortable right now. Your brain is reaching for an answer and coming back empty. Maybe you're thinking the Big Bang, but that just pushes the question back one step. Maybe you're reaching for conservation of energy, that it can't be created or destroyed, which means it was always here. But that's not an answer. That's an admission that you don't have one. You've been using energy your entire life, calculating it, measuring it from one form to another, and you've never actually known what it is or where it came from. Let me make this worse. Energy isn't a thing. It's not a substance, not a fluid, not a field, not particles flowing from place to place. And yet, everything you experience, every thought in your brain, every photon hitting your eye, every heartbeat, every star in the sky, is energy transforming from one configuration to another. You're about to discover that the question, where does energy come from, dissolves into something far stranger and far more profound than you ever imagined. Let's start with the comfortable lie you've been telling yourself. Energy is real, you think. It's the stuff that makes things go. You can see it doing things. A ball rolling has kinetic energy. Lift something up, and you've given it potential energy. Heat up water, and you've added thermal energy. This feels obvious because you can measure these things, predict them, use them. The equations work. You can calculate exactly how fast a ball will be moving at the bottom of a ramp if you know its height. Energy in equals energy out. It all adds up perfectly. Here's a simple experiment you can imagine. Take a rubber band, stretch it. You've done work on it, added energy to it. Now let it go. It snaps back, releasing that energy, maybe launching a paper ball across the room. Energy stored, energy released. Simple. Your explanation works perfectly. You put energy in by stretching, the rubber band held it as elastic potential energy, then converted it back to kinetic energy. You understand this. Wrong. What actually happened? And I mean actually, at the level of what's real. When you stretched that rubber band, you pulled polymer molecules farther apart. The energy you added, what was it? Where did it go? You'll say it's stored in the molecular bonds, but what does that mean? The bonds didn't change. The electrons didn't jump to higher energy levels like in chemistry. You just increased the distance between molecules. The potential energy is somehow hiding in empty space between molecules that are farther apart than they want to be. Think about what you just claimed. You said energy is stored in the space between molecules, but space is nothing. You've claimed that pulling molecules apart creates something from nothing, and that this something can later do work, can move things, can heat things up. Your explanation has sneaked in a miracle without you noticing. Here's what's really happening, and it's going to feel like I'm avoiding your question, but stay with me. Those polymer molecules want to be closer together, not because they're conscious, not because they have desires, but because of electromagnetic forces. Electrons in one molecule create an electric field. That field exerts a force on electrons in another molecule. When you pull the molecules apart, you're doing work against that electromagnetic force. The energy you added is a measure of how much work you did fighting electromagnetism. But that's not a thing you added. You didn't pour some substance called energy into the system. You moved charges in an electromagnetic field from one configuration to another. The configuration changed. That's it. The only thing that's real is the electromagnetic field and the positions of charged particles in that field. The energy is a number we calculate to describe that configuration. Now you're confused because I just told you energy isn't real, and yet I've been talking about it as if it matters. Here's the truth that's going to snap everything into focus. Energy is a bookkeeping device. It's not a thing, it's a property of things. More specifically, it's a property of how things are configured in fields, mostly the electromagnetic field, for everything you experience in daily life. Think about a book on a shelf. You say it has gravitational potential energy. What does that mean in reality? The book is a collection of atoms, roughly 10 to the power of 25 of them. Earth is another collection of atoms, roughly 10 to the power of 50 of them. Those atoms contain charged particles, protons and electrons. Every proton in the book is gravitationally attracted to every proton, neutron, and electron on Earth. The potential energy is a convenient number that represents the total work you have to do against all those gravitational forces to move the book from Earth's surface to the shelf. It's not stored anywhere. It's not hiding in the space between the book and Earth. It's a mathematical description of a geometric configuration of matter is the total work you'd have to do to replace the potential energy. What actually happens? The gravitational field accelerates the book's atoms downward. Their velocity increases. The kinetic energy is just a number, 1/2 times mass times velocity squared, that describes how fast those atoms are moving. As they fall, the potential energy decreases, and the kinetic energy increases by exactly the same amount. Not because energy is flowing from one container to another, but because these two numbers are different ways of calculating the same thing, the configuration of matter in a field, and how that configuration changes over time. You're starting to see it. Energy isn't stuff, it's math. But that makes it sound less important than it is, which is wrong in the other direction. Energy is the most important number in physics precisely because it's conserved. The total energy of an isolated system never changes. Not because energy is a precious fluid that can't leak out, but because the laws of physics are symmetric in time. Stop. Read that again. The conservation of energy is a consequence of time symmetry. This is Emmy Noether's theorem, one of the most profound insights in physics, and you've probably never heard of it. If the laws of physics don't change from one moment to the next, if an experiment gives the same result today as it would tomorrow, then energy must be conserved. It's not a separate law of nature. It's a mathematical consequence of temporal symmetry. Think about what this means. You ask where energy comes from, but energy is conserved because time is uniform. The question isn't about the origin of a substance. It's about why the universe has symmetries. And that's a completely different question, one that cuts far deeper than you expected. But I haven't told you what energy actually measures. Here's where it gets strange. Energy is the capacity to change configuration. That's it. A system with high energy can rearrange itself or other systems in more dramatic ways than a system with low energy. A hot gas has more energy than a cold one because its molecules are moving faster, colliding harder, capable of doing more work on a piston or heating a cool object. A compressed spring has more energy than a relaxed one because it can push things, accelerate them, change their motion. Every form of energy you can name is really about configuration in fields. Kinetic energy, how fast things are moving through space. Potential energy, how charged particles are positioned in electromagnetic or gravitational fields. Thermal energy, the kinetic energy of random molecular motion. Chemical energy, the electromagnetic potential energy of electrons in molecular orbitals. Nuclear energy, the strong force potential energy of quarks in nucleons. Mass energy, the energy inherent in the field configurations that give particles their mass via the Higgs field. Notice what just happened. I reduced everything to fields and configurations. There's no energy stuff flowing around. There are quantum fields, electromagnetic, gravitational, electron fields, quark fields, Higgs fields, and there are configurations of those fields, and there are numbers we calculate to describe those configurations. Energy is one such number. Momentum is another. Charge is another. These numbers are conserved because the universe has symmetries. You're feeling cheated. I promised to tell you where energy comes from, and instead I'm telling you it's not even a thing. But this is the answer. The question, where does energy come from, is like asking, where does north come from? Or where does multiplication come from? North isn't a substance that originates somewhere, it's a direction. Multiplication isn't a thing that has a source, it's an operation. Energy isn't stuff that comes from anywhere. It's a property of physical configurations that happens to be conserved. But you still want to know where the energy in the universe came from. The total energy of everything, all the mass energy and all the particles, all the kinetic energy of all the galaxies flying apart, all the potential energy in all the fields. Where did that come from? Here's where it gets truly bizarre. The total energy of the universe might be exactly zero. Stop. Think about what I just said. All the positive energy, mass, motion, heat, light might be exactly canceled by negative gravitational potential energy. When you calculate the gravitational potential energy of all the matter in the universe, of every galaxy attracting every other galaxy across cosmic distances, you get a huge negative number. When you calculate all the positive energy, the mass energy of particles, the kinetic energy of expansion, the energy in radiation, you get a huge positive number. Multiple calculations and theoretical models suggest these two numbers might be equal and opposite. Net zero. The universe could have literally zero total energy, which means the Big Bang didn't create energy. Which means the Big Bang didn't create energy. It created a configuration of fields with positive energy and negative contributions to energy. The universe is a free lunch. This feels like a trick, like I'm playing with definitions. This feels like a trick, but I can see energy doing definitions. Stars shine, but I can see energy doing things. My body runs on energy from food. Cars move. And none of that. My body runs on energy from food. Local concentrations of energy are very real and very important. The fact that you can convert mass to energy are very real and very kinetic energy, potential energy to thermal energy, mass to energy. This is all real and measurable and necessary for understanding how things work. But these are all descriptions of how field configurations necessary for understanding how things work. How they evolve. But these are all descriptions of how field configurations change. The universe started in a low entropy, highly organized physical laws. The Big Bang wasn't an explosion of energy into empty space. The universe started in a low entropy, highly organized state. With quantum fields in a particular configuration into empty space. That configuration has been evolving ever since. It was the beginning of space and time themselves, possibly quantum fields in a particular configuration. Entropy increases. That configuration has been evolving ever since. Your arm, with total energy traveling into your arm from some reservoir. It's already there in the chemical bonds of ATP molecules. The energy already there in the electromagnetic field configurations of electrons and nuclei, which came from the chemical energy in food. It's already there in the chemical bonds of ATP photosynthesis, converting solar radiation, which came from nuclear fusion in the electrons and nuclei, which came from gravitational collapse of a hydrogen cloud, which came from the distribution of matter in the early solar radiation, which came from nuclear fusion in the sun, which came from gravitational collapse of a hydrogen cloud, which came from the distribution of matter in the early universe, which came from quantum fluctuations in the first fraction of a second after time began. Trace it back and you don't find a source. You find a boundary condition. The universe started, or has always existed, depending on which quantum gravity model you prefer, with fields in a particular state. That state has been evolving. Energy is conserved during that evolution. You asking where did the energy come from is like asking where did the universe come from, which is like asking what happened before time began, which is a grammatically correct question that has no answer, because before is a temporal concept and can't be applied to the origin of time itself. Your brain hates this. You want a cause. You want something that made the energy, that created it from nothing or extracted it from somewhere else. But causes are temporal. Causes come before effects. When you're talking about the origin of time, of space, of the universe, causation doesn't work the way you want it to. This isn't me being mysterious or evasive. This is physics hitting the boundary of applicability. The questions you're asking require a framework that includes time, and that framework breaks down at the Big Bang. But let me show you something even stranger. Even this picture, energy conserved from the Big Bang onward, might be wrong. In an expanding universe, energy conservation isn't even strictly true. When a photon from a distant galaxy travels through expanding space to reach your telescope, it loses energy. The expansion of space stretches its wavelength, redshifts, it reduces its energy. Where did that energy go? Nowhere. It just decreased. Energy is only conserved in systems where time translation symmetry holds, where the laws of physics are the same at different times. In an expanding universe with changing geometry, that symmetry is broken. Energy conservation is approximate, not exact. You feel like I'm pulling the rug out from under you repeatedly. First, energy isn't a thing. Then the universe might have zero total energy anyway. Then energy isn't even conserved in cosmology. What's left? What can you trust? Trust this. The equations work. You can predict how things will move, how they'll change, how they'll interact. General relativity predicts the expansion of the universe, the bending of light around massive objects, the existence of gravitational waves. Quantum field theory predicts the behavior of particles, the results of scattering experiments, the energy levels of atoms to 15 decimal places. These theories don't tell you where energy comes from. They tell you how it transforms, how it's distributed, how to calculate it in any given configuration. That's what physics does. Physics is a mathematical description of how things change. It's not a metaphysical explanation of why those things exist in the first place. When you understand gravity, you can calculate orbital trajectories, but you can't answer why does mass curve space-time. When you understand electromagnetism, you can build motors and generators, but you can't answer why do charged particles create fields. These questions hit bedrock fast. At some point, the answer becomes, that's what the universe does. We can describe it with mathematics. We can predict it with incredible precision, but we can't explain it in terms of something more fundamental, because there isn't anything more fundamental. You want to know where energy comes from? The answer is, that question assumes energy is a thing that comes from somewhere. And it isn't, and it doesn't. Energy is a conserved quantity that describes configurations of quantum fields. It's conserved because of time symmetry. The total energy of the universe is possibly zero, possibly not well defined in an expanding space-time. Local energy is very real and very useful, but it's not stuff, it's a property. Now return to that rubber band. You stretch it. Where does the energy come from? From your muscles. Where does your muscle energy come from? From ATP. Where does ATP energy come from? From cellular respiration. Where does that come from? From glucose. Where does glucose come from? From plants via photosynthesis. Where does that energy come from? From sunlight. Where does sunlight come from? From nuclear fusion. Where does that energy come from? From the mass of hydrogen nuclei via E equals mc squared. Where does that mass energy come from? From the Higgs field giving quarks and electrons their mass. Where does that come from? You've reached bedrock. The Higgs field is a fundamental field. Its value, its properties, its interactions, these are the way the universe is. You can describe them, measure them, use them to make predictions. You cannot explain them in terms of something more fundamental. There is no more fundamental. This is the bottom. And here's the thing you need to understand. This isn't a failure of physics. This isn't us giving up. This is what explanation looks like when you push it all the way down. You wanted to know where energy comes from. You've discovered that energy is a calculated property of field configurations. Those configurations evolved from the initial state of the universe. And that initial state is either a brute fact or the result of quantum fluctuations in a multiverse, or something we don't have the physics to describe yet. None of those options give you the satisfying answer you wanted. All of them are more interesting than the answer you wanted. You're not separate from this. Your body is a configuration of quantum fields. Your thoughts are electromagnetic patterns in neural fields. The solidity you feel when you touch a table is electromagnetic forces between electrons in your hand and electrons in the table. The light you see is excitations in the electromagnetic field. The heat you feel is kinetic energy of molecular motion. Everything you experience is fields in various configurations, and energy is one of the numbers that describe the fields in various configurations and how they change. When you move your hand, you're not consuming energy like fuel burning up. You're rearranging field configurations. The ATP in your muscles had a certain electromagnetic configuration. Electrons and nuclei arranged in high-energy bonds. Your muscle proteins catalyzed the reaction that changed that configuration to a lower-energy one. And the difference manifested as motion, as mechanical work, as heat. The total energy of the system, you, plus the air around you, plus the earth you're standing on, plus the photons radiating into space, remained constant, or approximately constant, or possibly slightly changed if we account for the expansion of space. But let's not worry about that right now. The point is, you are this process. You're not a thing that uses energy. You're a temporary configuration of quantum fields that's maintaining itself far from thermodynamic equilibrium by constantly rearranging its internal field states, dumping entropy into the environment, staying organized at the expense of increasing disorder everywhere else. The energy you use isn't traveling into you from outside. It's already there in the chemical bonds, and you're transforming it, degrading it from useful free energy to useless heat, maintaining your structure as entropy flows through you like water through a whirlpool. This is magnificent. You started asking where energy comes from like it's a substance that has a source. You've discovered it's a mathematical property of the deepest description we have of reality. You found that the question itself was built on false assumptions, that the answer requires rebuilding your entire framework for thinking about existence. Energy doesn't come from anywhere. Energy is a consequence of symmetry, a conserved quantity in systems where time is uniform, a number we calculate to track how field configurations evolve. The universe doesn't run on energy. The universe is a configuration of fields evolving according to equations, and energy is one of the tools we use to describe that evolution. You don't need to know where it comes from. You need to understand what it is. The most powerful bookkeeping tool in physics, conserved because time is symmetric, measuring the capacity for change in systems of interacting fields. This isn't mysterious. This is magnificent. You're made of quantum fields whose configurations have been evolving for 13.8 billion years, and you're arranged in such a way that you can ask questions about where energy comes from. And the answer is that you are energy, configured into a pattern that can wonder about its own origin. And there's no deeper magic in the universe than that.